All right, in this next section, we're going to take a look at three variable systems. So the difference between this and what we did in the last section is we're going to add an equation and we're going to add a third variable. So now we're looking to try and eliminate one of the variables and one of the equations so that we get it down to a two variable, two equation system. Once we've done that, you know how to solve that with either substitution or elimination. In this first problem, we're going to solve the system using elimination. So we're given 2x minus y plus z equals 4, x plus 3y minus z equals 11, and 4x plus y minus z equals 14. So what we need to do is we need to choose two equations and we're going to line them up vertically. When we do that, we're going to take a look at what variables do we have in each equation. So we've got a 2x, a negative 1y, and a 1z. We've got a 1x, a 3y, and a negative 1z. And we've got a 4x, a 1y, and a negative 1z. So what you notice is that for each of our z's, we either have a 1 or a negative 1 as the coefficient. Those are the ones that we want to choose then. We're going to eliminate the z's. So I'm going to start with 2x minus y plus z equals 4. And underneath that, I'm going to put in x plus 3y minus z equals 11. I don't have to do any multiplication, division, whatever, to be able to get rid of that z now, because one's a positive and one's a negative. So I just add or subtract what's left. So I get 3x plus 2y equals 15. Now, I need to do this process one more time. I need to go 2x minus y plus z equals 4. And then I've got to choose the other equation that I didn't use in the first one. So I'm going to go 4x plus y minus z equals 14. Again, the coefficients for the z's are positive 1 and negative 1. So just add or subtract whatever you've got left. So I get 6x, but then my y's actually eliminate 2. So I'm left with 6x equals 18. From here, I can just work out what x is. So divide by 6 and x equals 3. Now, if I had two variable equations, I would stack them again and then eliminate either the x or the y. But I already have the x. So I can just substitute the x into the two variable equation that I got the first time, and then I'm going to get y. So I plug in 3 for x, and I get 3 times 3 plus 2y equals 15. So 9 plus 2y equals 15. Subtract the 9, you're left with 2y equals 6, divide out the 2, and y equals 3. So at this point, I've got two of my coordinates. I've got x equals 3 and I've got y equals 3. Now what I'm going to do is go back to one of the original equations. And in this case, I'm going to take the 2x minus y plus z equals 4, and I'm going to plug in the variables that I already know. So 2 times 3 minus 3 plus z equals 4. All I've got left to solve for is the z. So 2 times 3 is 6, minus 3 is 3, subtract the 3 over, and I'm left with z equals 1. So at this point, I have the solution 3, 3, 1, and you can see that I wrote it as an ordered triple. You're going to again check by substituting your ordered triple back into one of the original equations, but not the one that you use to find z, in order to figure out if you've got the correct solution. In problem number 2, I'm going to solve an equivalent system. And this time I'm given x plus y plus 2z equals 3, 2x plus y plus 3z equals 7, and negative x minus 2y plus z equals 10. So in this case, I'm going to eliminate the x's. So I'm going to stack x plus y plus 2z equals 3 over top of negative x minus 2y plus z equals 10. My x's eliminate. I'm left with negative y plus 3z is equal to 13. I'm going to go over and I'm going to grab 2x plus y plus 3z equals 7, And I'm going to stack that on top of negative x minus 2y plus z equals 10. Now again, in order to be able to eliminate the x in this equation, or in this system of equations, I'm going to multiply that bottom equation by 2. When I do that, I'm going to be left with negative 2x minus 4y plus 2z equals 20. So my x's eliminate, and then I'm left with negative 3y plus 5z equals 27. Now that I've got two variable equations, I can stack those, and I can use either elimination or substitution to find the solution to this system of equations. So I've got negative y plus 3z equals 13 stacked on top of negative 3y plus 5z equals 27. In order to do this, I'm going to have to multiply the top equation by negative 3. By multiplying by negative 3, I'm going to turn that negative y into a positive 3y, which is going to allow me to eliminate the y value. When I do that, the 3y's eliminate, and I get negative 4z equals negative 12. Divide out the negative 4, and z equals 3. So now that I've got z equals 3, I can take that z value and I can plug it back into one of those two variable equations. So I'm going to choose to plug it into the negative y plus 3z equals 13. When I do that, I get negative y plus 3 times 3 equals 13, which gives me negative y plus 9 equals 13, and negative y equals 4. Divide out the negative, and you get y equals negative 4. Now you'll notice that there's no directions on the right side of the slide because we need all of the room on this slide to be able to work this problem out. So what I did was I rewrote that I had y equals negative 4 and z equals 3. This just reminds me of the variables that I've already solved for. Now I'm going to choose one of those original equations, and in this case I'm going to choose x plus y plus 2z equals 3 and substitute the two values that I already know. So I get x plus negative 4 plus 2 times 3 equals 3, which is x minus 4 plus 6 equals 3, x plus 2 equals 3. Then subtract the 2 over, and you get x equals 1. This is going to give me an ordered triple of 1, negative 4, 3. I'm going to choose one of the equations that I did not solve for or did not use in that last step. So I'm going to choose negative x minus 2y plus z equals 10, and I'm going to plug in all of the variables or all of the coordinates that I already know, which is all of them. So negative 1 minus 2 times negative 4 plus 3 equals 10. So I get negative 1 plus 8 plus 3 equals 10, and that's going to give me 10 equals 10, which is the correct solution. So I know that the ordered triple of 1, negative 4, 3 is the solution to this system of equations. So finally, I'm going to use substitution to solve for a system of equations. And I'm given 2x plus 3y minus 2z equals negative 1, x plus 5y equals 9, and 4z minus 5x equals 4. Now, since the x in the second equation has a coefficient of 1, that's going to be the easiest one to isolate and then substitute into the other equations. So when I take x plus 5y equals 9, and I isolate x, I get x equals negative 5y plus 9. I am then going to substitute that value in for x in both of the other equations. So 2x plus 3y minus 2z equals negative 1 becomes 2 times negative 5y plus 9 plus 3y minus 2z equals negative 1. Negative 5x plus 4z equals 4 becomes negative 5 times negative 5y plus 9 plus 4z equals 4. Go ahead and distribute both numbers through the quantities, and you're left with negative 10y plus 18 plus 3y minus 2z equals negative 1. And over on the other one, 25y minus 45 plus 4z equals 4. Next, I'm going to do whatever is next for each equation, whether it be combining like terms or shifting something over, or could be just putting everything in the correct order into standard form. So the first equation, I've got negative 7y minus 2z plus 18 equals negative 1. And in the second, 25y plus 4z minus 45 equals 4. Go ahead and do your addition and subtraction. You're left with negative 7y minus 2z equals negative 19, and 25y plus 4z equals 49. We can then take those two equations, two variables and two equations, stack them for elimination, and we can go ahead and do that. So I'm going to multiply the top equation through by 2. This is going to give me negative 14y minus 4z equals negative 38. So those z's are going to eliminate, and you'll be left with 11y equals 11, which means that y equals 1. We can then take that y equals 1 and plug it back into any of our equations. So I'm going to take that x equals, or x plus 5y equals 9, plug the y into there, so I get x plus 5 times 1 equals 9, or x plus 5 equals 9, and then x equals 4. So now I have a y value and I have an x value. All I need now is to find the z. So 4z minus 5x equals 4. Take that 4 for the x value, plug it into that equation. 4z minus 5 times 4 equals 4. So 4z minus 20 equals 4. And you get 4z equals 24. And eventually z equals 6. That gives you a solution of 4, 1, and 6.